The question today is to find the top 3 pocket Pokemon in terms of total stats for each type of pocket Pokemonster. The dataset provided is can be accessed in the Kaggle link here. The dataset contains 721 Pokemon and 21 attributes, or you can view it as a column. So the task we reiterate is to find the top 3 Pokemon in terms of the total statistics, which is the column total here, for each type, the primary type, type 1. So let's see how to access this. So first we import the libraries we will use. Then we can download the dataset as a CSV file, and we read the CS file into a pandas data frame. Then we can observe the first few lines in the data frame. We can see the first 5 records and also the 21 attributes or columns here. Optionally, you can rectify the data type of some categorical and string attribute to their correct type, but these will not affect the outcome of this question. Then we use describe to show some statistics. We can see the numerical statistics, the categorical statistics, and the booting statistics. So it's quite common. So let's get into it. So first, we use the group by function to combine a data frame by the column type 1 as stated in the question. For each type of Pokemon, like each the type can be grass, fire, steel, dragon, etc. So we group the data frame by the primary type 1. So in Python, we can just use the group by function, and by the column name we specify here, and we can see that we can access any of the group by using the get group function. For example, here we would like to access the Pokemon in the steel steel type. Then we can just write the data frame dot get group and specify the name of the type as steel, and we show the first 5 records, so we can see all the steel Pokemon is combined in this group. Then we use the lambda function to find the top 3 largest in terms of the total statistics in each group. So the syntax is here, and I'm not going to elaborate too much into it. It's quite straightforward. So we just pick the largest 3 in terms of the total statistics and apply this lambda function to each group. The only thing we need to pay attention of is the reset index. So the currently is the result if we apply the reset index function after applying the n largest function. If we do not apply this, the result will becomes group by type 1. but the index is not uh, is not how to say in accordance with the default index. So by applying the reset index, then we will reset the index of the data frame and use the default one instead. So and also we use drop to drop the we we set into true, so they will insert index into the data frame columns. So we can see after we apply this reset index, the index will be reset with the new columns. So let's run it again, and then we can see that the index was reset with from 0 to 53. Why it is 53? Because there are 54 rows. Because there are, let's see here, let's see the statistics. There are, how many types are there? We can see that there are 18 primary types, and since we would like to find the top 3 Pokemon in each type, so there will be 3 times 18, which is 54 records. So we can see that we can see for box, the top 3 Pokemon of the type box were found here, and these records was sorted in terms of a total, which is the largest in each group for bug, for dark type, for dragon type, for electric, etc. So the task can be done in Python quite simply. So how about SQL? I'm not going to open the MySQL CLI, or I just go to use the SQLite database, which is embedded in Python. So as usual, the syntax was quite straightforward. You can find these syntax in the official website of SQLite. So we build a connection to connect to the SQLite database and create a cursor object. Then we first transform the initially read data frame Pokemon slash underscore df into, so we load the CSV into a data frame, then we transform the data frame into a database in SQLite. So we can use and the syntax is to SQL. It's quite simple, and literally just from data frame to SQL database. So we name the database as PocketStats. Then we would like to use SQL to achieve the same result. So the SQL query statement can be decomposed. First, we can just look at the whole statement is here, but if we decompose it to get a clean or more straightforward look, so it can be decomposed into an outer query and an inner query, or you can state it as a main query or a subquery. For the subquery, we select all the columns from the PocketStats database. Don't forget the PocketStats database, which was transformed by the initial data set from CSV to data frame and from data frame to a SQL database. So we select all the columns here, and we use the partition by clause. So partition by quite similarly to group by, but in here we do not we are not going to calculate some metrics like sum or a median or maximum, so we use partition by. So partition by basically is a window function that assigns a unique row number to each row with the specified partition. So we partition by the type 1, which is the type of the Pokemon, and order by, which is sorted by the total statistics, which is required by the task definition, task requirement. So all this is again quite straightforward, just from the Python syntax into the SQL syntax. Okay, and don't forget that you need to use descending because we want to find the maximum. So the first three will be the maximum if we use sorted in descending order. So then we pick the row number here and over the partition by then the first three records in each group in each partition will be the largest in terms of type, in terms of total in each type. Okay, so an additional row number columns will store the row number, which is the window function that basically assigned to each row within each partition. And then this is the inner query, which basic it does the same job as the Python code we used previously. And in the outer query, what we still need to do is that in these inner query, we are partitioned by the type and sorted by the total statistics, but we only want the top three Pokemon in each type. So we just where is it? We just select the row number which is smaller or equal to 3. Don't forget the row number is a window function that assigns unique number to each row within each partition. Okay, so the whole query can be seen here. Just combine, just insert the inner query into the outer query, then you will get, sorry, this is not outer, this is the whole query. This is the complete query can be seen here. So then we can just copy it and paste it into a SQL string. Then you can get the column names either from the tricky one here is that SQLite does not support temporary table. So in this in the complete query, we added additional column which is row number, but in the end we will like the result that is the original data, which does not contain the column row number. So we need to get rid of this column after the query, or you can here one approach is that you can store the query result as a table and drop the column using outer table drop column n, and you can drop this one. But here we use the dynamic SQL string, which that we the dynamic part is that we dynamically assign a column name, which that we exclude the row number, that we does not select the row number. Why we need the dynamic SQL is that if there are like say 10,000 columns, you cannot it's not feasible to list all the columns here. So we use a dynamic structure SQL string here, and the column name uh, aside from the row number is basically not sorry, it's like uh, is the original column names of the imported database. Okay, so still is some syntactical terms here formatting the SQL. So basically, we replace the dynamic part by the exact column name here, and in the end, we execute the SQL and fetch the result. And if you want to commit your changes, you can do it. And finally, we close the connection. Since we obtain the result here, which is indicated by result B, we then transform it back into a pandas data frame, result B, and we like to see whether the result is the same as we obtained by using the directly using the Python syntax. First, we can see the first few lines here look quite correct, but since they are 54 record, we can simply use the compare syntax to compare the result A, which is the result we use the data frame and apply the lambda function and the n largest function to each group and compare it with the SQL result we obtained latestly. So after carry out uh, this code, we can see that there's no any difference between self and others, and the task was accomplished. That's it.